problem wants us to find the power series for 5 arctangent of 2x. So the first thing that we're going to do is see if this function matches any of the 4 functions that we know the power series for. And since it doesn't, we have to rely on something else. So what we can do is use the fact that when we take the derivative of this function, we're going to get something similar to 1 over 1 minus x. So the derivative of arctangent is 1 over 1 plus x squared. So taking the derivative of the function that we are given, what we're going to do is plug in 2x wherever we have an x here, the derivative. So here we have that 2x, and then using the chain rule, we're going to multiply by 2 in front. And then that 5 carries along because it's just a constant. And then simplifying that a little bit, we have a 10 in front, and then the bottom simplifies to 4x squared. So we know that the power series for 1 over 1 minus x is this sum of x to the k. So now we want to rewrite this derivative to look more like 1 over 1 minus x. So to do that, we factor out a negative sign on the bottom. So we have that 1 minus something in here. And then the 10 just stays out in front as a constant. So now, to find the sum of this function, we're going to plug in this negative 4x squared in the place of x, wherever we have an x here in the sum. So that's what we do here. We plug in this negative 4x squared, and that's all to the power k. And then the 10 stays outside the sum. So distributing this k, we have a negative 1 to the k, 4 to the k, and then x to the 2k. And so now that we have the simplified sum of our derivative of the original function, to find the power series for the original function, we have to take the integral of this answer. So now we take the integral of the sum with respect to x. So all these terms that don't have x in them stay as they are. So we have negative 1 to the k, 4 to the k, and then we're going to add 1 to the exponent here, and then divide by that new exponent. So we have x to the 2k plus 1 over 2k plus 1. And then this is our final answer for the power series for 5 arctangent of 2x. So the last part of the problem wants us to state the interval for which this function is equal to its power series. So we know that the function 1 over 1 minus x converges between negative 1 and 1. So what we're going to do is similar to what we did before, and we're going to plug in the negative 4x squared for x here. And then the next thing we're going to do is solve for x. So we divide by negative 4. And then next we're going to take the square root. But since we have a negative number here, we can't get a real answer. So we're just going to look at this left operator here. So taking the square root, we have x is greater than 1/2, or x is less than 1/2. And this is the interval for which the function is equal to its power series.